Hi, everyone. Thanks for tuning in. Thanks, Deb, and thanks to AFAC and the Center of Excellence for allowing me this opportunity to discuss this work. Before I get started, I just wanted to acknowledge the traditional owners and elders, both past, present, and future, of the Ngunnawal people in which this work presided on. I'd also like to acknowledge the co-authors and also the Fire Management Unit here at ACT Parks, along with the numerous crew who helped me collect this information. So we'll see if we can get technology to work, and we'll go forward. So today, what I wanted to discuss was sort of the evolution of our fuel moisture program. Sort of take you through a little bit of a story of why we thought or why we require more detailed information. Look at some case studies, and then also discuss some of the lessons that we've learned and potentially some of the things that we look to do in the future. So why more data? There's a whole host of reasons why I think we might need more data. First and foremost, for the prescribed burn program in the ACT, we're trying to run a program of integrity. It's very important that we're achieving our objectives of both protecting and enhancing the ecological values while also reducing fuel. And in this talk, I'm going to talk specifically about the ACT experience. You can see on the slides, there's a number of different reasons that you might want to do it. For the ACT, we've had as we've come to the end of our regional fire management plan, we've had a lot more difficult burns which rely on moisture differential or ridge top. Shrinking burn windows has become more of an issue, and there's always a higher level of scrutiny for implementing these burns, especially when you start talking about smoke or the impact of smoke. So really, the story sort of began back in 2013, and what you see here is the smoker's burn, which is roughly 6,000 hectares, which is shown in the green color here, and we'll see if the mouse works for this area here. And this burn we attempted to do in March, and there was numerous sensitive features, and I'll just see if that works. So numerous sensitive features that were highlighted in this yellow platypus figure that I've drawn. And these areas need to be excluded, and I guess the question that we had was, how could we be confident that these areas would be excluded? And because this was a very large burn, there was a large portion of stakeholders that were quite furious about the implementation of such a large burn with so many numerous features being threatened. So to determine the suitability of this burn, we developed a number of different test burns which were part of our go, no-go to determine whether we were within prescription. And as it turned out, this was a very difficult burn to implement because it's such a large area. We were finding shading from smoke. We were doing fine dead fuel moisture collection, which we believed we were within a suitable range. But at the end of the day, perhaps it was a little bit too wet, and we did not achieve our objectives as we desired. A couple weeks later, following this burn, we looked to implement the stockyard spur burn, which the intent of this burn was to sort of establish a black edge or some depth along a walking trail, shown here in green. Once the burn was lit, what was found is that it just continued to want to light and didn't really want to stop in this along the slope. And the red line there is the extent of where the fire went. Eventually, what we had to do was, and here's just a photo of the backing fire that we got from this burn, but due to downslope winds and dry slots, we ended up putting crews in here to put a check line in and went direct on a number of different areas as well. And perhaps that when we lit this burn, it was too dry, but we didn't have the detailed fuel information beyond that fine dead fuel that I discussed a minute ago to determine that. So we got to thinking, and from that point, we started to investigate putting fuel sticks out along burn areas, and areas in Victoria and New South Wales were also testing these 10-hour fuel sticks, which I'll go into more detail a little bit about what that means, the 10-hour fuel sticks. But So we started playing around and we started putting fuel sticks on different aspects so we could test that moisture differential. And what you can see on the screen now, I believe, is the Hardy's range burn in 2015. And what you can see here is a road that stops along a ridge line, and then for about 4 additional kilometers, there's no direct containment line. And if this burn was to get over to the eastern side of the slope, an additional 10 to 12,000 hectares would be burned. And so what we did is we put them out at the end of this road here on both the west and the east aspect. And once we had that differential in the fuel sticks, we then did a test fire, and we brought in the idea was to do a test fire and then bring in a helicopter to support the operation. And so this is what it looked like when we lit it. We waited for a rain event to come, and we had a lot of confidence that the rain would actually come and there would be sufficient. So with the help of 2 helicopters, one lit it and one was using a bucket on the northern end to help keep it in check. We let it burn for about 2 to 3 hours, and then the rain came, put a majority of it out, where I believe the next slide will show you the next day we just had a handful of smokes along a handful of smokes along the ridge, and we sort of waited a couple of days till it dried out, and then we went to the helicopter and crews to put more fire in. So I'm just going to switch here and see if this works. So just bear with me with technology here. Let's see if this. So hopefully, what you can see here is a video showing the Hardy's range burns. We brought the helicopter in, lit off the ridge and the various spur ridges, supported by crews. And then, let's see, here. Basically, continue with that fire. The black edge that we created a couple days prior actually held, and the burn never went to the to that eastern side. So with the success of the Hardy's range burn, we sort of had some confidence to continue with this fuel moisture program, and in 2016 we formalized it, and we looked to establish some permanent plots. So what you'll see here on the right is a map, and these green little flags are now our 5 permanent fuel moisture plots. And so what we were looking to gain was fill in some knowledge gaps. We wanted to create historical data sets, and by choosing the 5 different locations, we wanted to get a good representation of the ACT, both in different elevation profiles, forest types, aspects. And probably most important for us was to make sure that the collection process that we were building was actually achievable, so that we could do it with our current workforce. So what we actually did was 5 permanent plots where we would collect live fuel moisture and dead fuel moisture, and I'll go into more detail in a minute, and basic weather data. And then we also would establish fuel moisture collection sites along different landscape burn areas. And this table just shows you the difference. So at the permanent plots, we're collecting these different fuel parameters in addition to weather. The only difference is for the burns, this past year we started testing the 100-hour fuel at just 2 sites across the burn. The 10-hour fuel sticks, we generally will pick 4 different locations across the burn, and live fuels are only selected at the permanent plots. Frequency, the live fuel plots are done fortnightly, and the burn areas we might start at every 2 to 3 weeks, and as we approach the burn area and the burn season, and during the burn season, we usually go to weekly, as the information can change that frequently. This is just a visual representation of what our collection sites looked this year. And with the blue pluses being the landscape burn areas, and the red just show you where the 100-hour plots are located. And on the right-hand side, you'll just see a map of the Tango Spur burn, and you can see that we have the 4 different crosses for that burn at different locations across that burn. So at the end of the day, we're probably looking at 25 to 30 sample sites across the ACT, which, based on our size, I think is a pretty good sample size for us. Taking a closer look at live fuel, and what we're doing is we're trying to determine what the flammability of elevated fuels are, and I think that's important to know, not only for prescribed burning, so what might occur if your burn gets into your elevated fuels or your canopy, but also this information could be useful for bushfires. For what we're actually sampling, we're looking at small shrubs and small trees, or shrub species and small trees, and we've chosen 3 different species, or 3 different types. So we take the dominant eucalypt in the area, Divisia, an understory shrub, and also 1 wet species, which is acacia. And what we're actually sampling is just the living leaves and twigs, and looking for material less than 6 mils, and we're trying to get a representation from different plants in the area. And as I mentioned, this could be important for not only prescribed fire, but also bushfire behavior. In terms of overall sampling, we're looking at basic weather observations, which are shown. And then we're looking at the dead fuel moisture collection as well. So what we're using for the dead fuel moisture collection is a US metric of 1, 10, and 100-hour time lag. And for those who are not familiar with this, what the time lag refers to is the rate at which fuels respond to changes in environmental conditions, whether it be wet or dry. So specifically, the amount of time that it takes for a fuel particle to lose or gain 63% of the difference between the initial moisture content and the new equilibrium. And this is, of course, at a constant temperature RNH. So simply put, for the 1 hour of fuels, which is the first thing I was going to talk about, less than 6 mils, I think of grass, and if it rained, within an hour with a constant RH and temp, you could successfully burn that material. You might get bogged in certain portions, but the fuel would light at least. So we collect 1 hour fuels, and we're looking at both surface and the profile. So the surface being that fuel that's on top, which has minimal decomposition, you can still make out, and the profile is underneath that top layer, which is in direct contact with the soil, and it's sort of hard to make out. You've had pretty much significant decomposition, but still a little bit recognizable. The picture on the right here is a Wilktronics machine, which many people would be familiar with, and that's how we gain the fuel moisture content with that. In terms of the 10-hour fuels, that's 6 to 25 mils. These sticks are imported from the U.S. As I made mention to you earlier, a number of jurisdictions across Australia have been playing around these sticks for the last, I think, 5+ years. You can get them attached to weather stations through Campbell Scientific as well. In the U.S., from the times that I spent there, this was sort of a quick and dirty last step, was a part of your go, no-go checklist where you would, the burn boss or DivCom in our case, would check the 10-hour sticks to make sure they were within the parameters before you decide to lit ahead. So for our cases, what we've been doing is placing sticks at various aspects so we can test the different moisture across the burn area. Typically for us, it's northwest and southeast aspects. For 100-hour fuel, and this is where the majority of the talk will go to, is the larger fuel, 26 to 75 mils. I make mention here that we are permanently looking at, we're using it just at the permanent sites, but we've since expanded that to burn areas. And what we're looking to do is, on the left-hand side, bottom left-hand side, we're looking at fallen branches or logs. We take a small cookie or a wafer, and then we put it in the oven, and we're looking at the difference in moisture in that. And for this year's burn year, we tested basically two different sites, so one northwest and one southeast for each burn area. So looking at some of the data that we've had, so in last burn season we had the Devil's Gap burn, and what you can see on this graph is our four different sticks broken down between northwest and southeast. And as you can see here, we were unable to implement the burn until we got to the first or almost second week of May here, where we had that nice differential, and we ended up getting good results with this burn. I'm sorry, I should mention the green bar that you see here is roughly the acceptable range, or what we believe to be the acceptable range for fuel moisture. So it's roughly 9 to 16% for dry eucalypt. On the left-hand side now, you'll have an example of our live fuel moisture content, and this is going back to the beginning of our sampling. So I would just say that we're starting to learn about live fuel moisture. We're starting to learn about, or trying to identify what trends there might be. Live fuel moisture will be quite slow to change and can be tied to large portions of rainfall and obviously different parts of the growing season. So this is something new that we're still sort of learning about. So if you fast forward a little bit to this season and to where we began this conversation, we went to implement the smokers burn because again we didn't achieve our objectives in 2013, and so what we were trying to implement here was this green portion, and you can see some of the plus marks here where you see our sampling sites across the burn area. And when you look at our data from one of the permanent sites, which happens to be in the north end of this burn area, and I'll just introduce this orange bar. So what you've got here is what we believe is the acceptable range in orange, and then the green bar would be the 10-hour fuel that we discussed before. In each of the colors, orange is 100-hour and the green is 10-hour. And so from that period of when we're trying to, let's see if this is going to click. Sorry, I'm having, unfortunately one of my animations is not working, but we'll just go through it. Is what I was trying to show is when you look at our burn seasons, which is historically middle of March to let's say the middle of April for the last couple of years, we've had very few opportunities where both 10-hour and 100-hour were both in the acceptable range. And what we were going to show here, although the elliptical is not showing, is in April this year we did find a portion that was within the acceptable range. The honeysuckle site, which happens to be in the southern portion of this burn, the same type of thing. We finally got into an acceptable range toward the early part of April this year. Taking a closer look, if you look at the 10-hour sticks for the smokers burn, you'll see portions of the northwest were quite wet. Southeast, one portion was quite dry, was right in the acceptable range, as well was another of the northwest sites. It's a shame the elliptical things are not working because they're wonderful to see. I'm sure you appreciate that. Looking at the 100-hour, so these are the new sites we put in. Again, you can see the large rainfall. It was quite dry during the bushfire season. We had big rainfall, and it was all about drying and trying to find acceptable wind. We got a little bit too dry after a while, and then following some more rainfall, we finally got into that nice acceptable range toward the middle of April. And so I'll just switch to another video and just show you. Let's see how I get rid of this one. I do want to close this video. So this here is a video of what it actually looked like when we lit the burn. and sort of some of the results that we got. So we started the smokers burn in 2000. I'm sorry, in the 10th of April, following the moisture checks on the 9th. Our fuel moisture was within 19 and 26% for 100-hour fuels. The actual lighting was completed on the 13th of April, but it actually continued to burn through the 21st of April. And so what that information sort of gave us was confidence that the south and east slopes would not burn, and that the sensitive features that I sort of outlined in the beginning of this discussion would be protected. Because what we saw in 2013 was low and no intensity, and so we could expect a wide range of intensities, which we did find. So we had some moderate intensity on some of the steeper northwest slopes. We even had some more severe higher intensity, which I believe is good when you're looking at burning across a large landscape. And so other burns were held off this past autumn due to the information that we collected from our fuel moisture site. So in one case, we had a DivCom go out and they identified that the burn site was too dry, and our data did confirm that. In another case, we found out that it was a little bit on the wetter side in some areas, but dry in others, and we ended up going ahead because in those situations, I feel like it's a little bit better to go on the wetter end, and we were able to implement that burn, and we had good results. And so I sort of coming up with the term that we need to hashtag trust the data a little bit, because it can provide us quite useful information. So I'll just switch back to the presentation. Let's see. So lessons learned through this process is that the 10-hour fuels are providing more information or more value than the 1-hour fuels, and that's mainly because when you're taking fine fuels, the current conditions really are affecting your values, and there's too much variability to make good decisions on that 1-hour fuel. It's too variable. That sample size, so the amount of samples you're taking and the amount of rain gauges are very important, and this is mainly because from our experience, most of the late summer or autumn rain is very convective based, so we're getting a lot of variable patchy rainfall across the areas, and so we're finding a lot of variability across some of these larger burns. The frequency of sampling, so as I mentioned, we start probably every 3 weeks with the burn areas, but we found it very important because of that variability in rain to not only increase that to weekly, but also to continue through the burn implementation. And I would explain that or go into more depth in a second on that. And I guess most importantly, the 100-hour fuel sampling has been essential. And I guess the reason why we've come to those conclusions is from past experiences, we've had some pretty large rainfalls, and following some drier summers, I think what we found is that the rain has been somewhat of fool's gold. So whether it's runoff, evapotranspiration, or just the rate at which it's actually flowing, that we're not seeing that value. It's not absorbing into the fuel, and so we're getting a better understanding of which fuels are likely to burn with this 1-hour fuel. And I guess I've used the term acceptable range because acceptable range can actually can mean a lot of different things, and I guess from what we learned is you're testing your fuel and you're saying, okay, I'm at your acceptable range is very much relative to where you are in the potential drying. So some of these burns, as I mentioned, can go on for a week or even 10 days, and you might be right in the middle of that acceptable range. But where are you going to be 10 days down the line or 5 days down the line? You might find yourself very much below the acceptable range and too dry. And we've, one situation this year was, we were hopeful that we'd get some rain because the burn, although it was doing a really nice job, at some point we did want it to stop burning. and luckily we did get some of that rain. So I think we're still learning and playing around with acceptable rain. And I'll switch to probably the last video here. And this, let's see, sort of this video. I'm sure that's showing maybe. It was actually filmed in May. And this is again showing the value of the power fuels where very small amount of power factors, but we're hoping to avoid and burn these fuels during rainy hours. We have the confidence with our fuel moisture data and the result, as we sort of showed. We had really nice burning conditions and fuel, consuming fuel that we wanted to in the past, when we didn't have this detailed information, probably would have thought maybe in May already missed the opportunity to implement some burns, but with the changing climate, again, it's giving us more confidence to continue. So lastly, to end up would be just the future work that we've identified. So I'd like to see us put some more 100-hour fuel plots out next year across the different burn areas, again, to deal with the variability across the range. And again, we need to fine-tune what that range is. We've sort of just taken a best guess that it's somewhere between 19 to 26. And so we just need to continue to test it and see if we're happy with the results we're getting within that fuel range. I'd like to get a better understanding between live fuel moisture and flammability. So there's potential integration with the Australian flammability monitoring system. And there's a lot of some other researchers who are interested in continuing to learn about live fuel moisture and how that affects fire behavior in Australia. I think there's a potential to extrapolate data for fuel moisture maps. And again, we're doing a lot of testing on the ground and going back to, I guess, the flammability monitoring system. I guess if you could increase your efficiency through different satellites or moisture maps, that would be beneficial if possible. And the last is some work we're doing with a consultant, which is trying to create fuel moisture assessments using LiDAR-derived DM and vegetation metrics. So with that, I'll thank everyone for their time, and it's sort of weird talking when you don't hear anything, so potentially no one's actually listening to this right now, and I'm just talking to myself. But nonetheless, I'll open it up to any questions if you have them. Thank you.
I'll just open the lines for you, Brian.
Thank you.
The conference is now in conversation mode. All participants are now unmuted.
Okay, does anyone have any questions for Brian?
Brian, it's Lee from Bushfires in Northern Territory. How are you going?
Good, Lee.
Brian, have you run a similar technique, I guess, in spring and looked at opportunities in spring after, obviously, a wet winter?
Lee, I haven't. We haven't here yet. I think obviously this work could be does relate to that time period, and I think it could be very useful for our planning purposes at this time, and sort of the windy air conditions that we have here. It hasn't fit in for us, but I think it's something as we get more organized we should be thinking of. Potentially, would you think that's something that could be useful in the Northern Territory?
Oh, I'm not sure. I was really just referring to my time back in Victoria. I just found that I did some really rudimentary sampling on my own 6 or 7 years ago, and found when you talked about in your presentation about additional opportunities, I had a number of burn ICs come to me in spring saying it was too wet, but once they got out there and lit up, they found that it wasn't wet at all. And as you referred to fool's gold, similar thing sort of happens in sort of mid to late spring, where rainfall events, probably the effect only lasts for up to 24, maybe 48 hours, and then the conditions are almost ideal because you've still got that underlying dryness, but the fine fuels have underlying wetness, I guess, and the fine fuels have dried out and available for burning. So, yeah, I just wondered how this technique would go in a spring scenario.
Yeah, I think it would go well. I go back to two things. One, hashtag trust the data, because I really believe, there's times where I think it'll work in both ways. I think we're all very good at what we do, and inherently we're trying to, do the right thing, but we either think it's too dry and it's probably just right, or it's too wet and it goes the other way. And the other thing is that acceptable range is knowing where you are in that spectrum, or knowing where additional weather is coming up is going to have to play a key role. So you might be within that nice range, but if you're going into a very long drying trend, then that might be something you consider.
100%. No worries, thank you.
Thanks.
Thank you. Any other questions out there for Brian? No, it looks like everyone's quite happy and content with what you've told them, Brian.
Great. Well, yeah, thanks again, and appreciate the opportunity to talk about this work that we've done here.
Yes, and I thank you on behalf of everyone that's listening for presenting today.
Yep. Cheers.
Thanks.
Thank you, Brian.